Welcome viewers, in this video we will see the solved problem based on the transformer on loaded, when the transformer is loaded condition. This is a part 1. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. Now we will see the problem 1. A 3300 voltage bar 300 voltage, a single phase transformer gives 0.6 ampere and 60 watts as a ammeter and wattmeter reading when the supply is given to the low voltage winding LV winding and high voltage winding is kept open. Calculate the magnetizing current and iron loss component. So this is coming under the open circuit test. The high voltage side is kept open, the supply is given to the primary winding. Right. Now we will see what are the given data available. So the current flowing in the primary I naught, because there is no load is available, so it is called as a I naught, 0.6 ampere. W naught, power taken by the primary winding under the no load condition, so that it is W naught equal to 60 watts. And primary voltage is 300 and secondary voltage is 3300 voltage. Here the low voltage side, the voltage is applied to low voltage side and high voltage side is kept open, so that 300 is taken as V1, 3300 is taken as V2. See this, the ratio available here. This 300 side is taken as a primary winding, 3300 is taken as secondary winding, that is kept open. Now we need to find the magnetizing current and iron loss component. So the power is given by this wattmeter reading is given, is available. So that is nothing but V1 I naught into cos pi naught. The power given by the wattmeter reading, the power taken by the transformer under no load condition is nothing but V1 I naught into cos pi. So from that we can find the cos pi value. So that cos pi equal to, bring this V1 and I naught in the denominator. So that cos pi naught equal to W naught divided by V1 I naught. W naught is given 60 watts and V1 is 300 and I naught is 0.6. So all these values are available, I naught, W naught and V1. So by simplifying this, what we got, 0.33 power, the cos pi naught equal to 0.33 is a lagging. The value is 0.33. Now we got the value of the cos pi. From that we can easily find the magnetizing current and the iron loss component. So the magnetizing current I mu is given as I naught sin pi naught. The already formula is given. It's a magnetizing current. That separate video available for the no load condition. So cos pi naught equal to 0.33 we calculated. So that pi naught equal to cos inverse 0.33, that is equal to 70.52 degree. The angle between current and voltage pi naught is 70.52 degree. So I mu equal to I naught sin pi, that is equal to I naught value is 0.6 into sin pi. Pi value just now we calculated. So sin 70.52. So by simplifying we got 0.566 ampere. So the magnetizing current is 0.566 ampere. This magnetizing current is the responsible for producing the flux in the primary winding under no load condition. And then we will see the iron loss component. This iron loss component responsible for the iron loss happen in the primary winding. IW equal to I naught cos pi naught. So that is equal to I naught is 0.6 into cos pi naught already available. Cos pi naught is, that is cos pi naught equal to 70. This pi naught is 70.52. So cos 70.52 is there. So by simplifying this, what we got, 0.198 ampere. So the iron loss component is 0.198 ampere. So we calculated both the magnetizing current and iron loss component. Now we will go to the second problem. A 3300 voltage bar 220 voltage 30 kVA single phase transformer takes a no load current of 1.5 ampere when the low voltage winding is kept open and the iron loss component equal to the 0.4 ampere. Calculate no load input power magnetizing component and power factor of the load current. We need to find the no load input power, then magnetizing component and power load, power factor and the no load condition. So, this low voltage winding is kept open. So, based on the given data, the V1 or E1, the voltage applied or voltage induced is 3300 voltage. V2 or E2 is 220 voltage. This data is available. And kVA is given as 30 kVA. This kilovolt means it multiplied by 10 to the power 3. So, 30 into 10 to the power 3 VA. Then no load current I naught is given 1.5 ampere. The IW, the working component, is given as 0.4 ampere, right. So, this current is the 1.5 ampere, this iron loss current is 0.4 ampere. So, these are all the given data. So, from the no load input power is given, no load input power, this we first will find the no load input power, that is nothing but W naught equal to V1 I naught into cos pi naught. First question is no load input power, W naught is V1 I1 cos pi naught, right. But the IW is given, IW equal to I naught cos pi naught, right. This IW is given, that is equal to I naught cos pi naught. So, that W naught is written as V1 into this I naught cos pi naught is nothing but IW, because IW value is given, this cos pi value is not available. So, we can replace I naught cos pi naught as a IW working component. So, V1 is available 3300, the iron loss component is given 0.4. So, by multiplying this we got 1320 watts, right. So, this is the formula. In this value is replaced by IW, because IW value, the working component current is given, pi naught is not given, so that we are replacing. Now, we got the no load input power 1320 watts. Now, we will go to the magnetizing component. So, the magnetizing component and power factor. So, IW equal to I naught cos pi naught. So, cos pi naught can be calculated as IW divided by I naught. These two values are available. So, from that we can find the cos pi naught. So, that is 0.4, working component is 0.4, the no load input current is 1.5. So, by simplifying what we got 0.267, the cos pi naught, the angle between current and voltage, this cos pi naught, this is pi naught, the angle between current and voltage is pi naught, the cos pi naught value what we got 0.267. Now, we will concentrate to find the magnetizing component I mu. So, I naught square equal to IW square plus I mu square. Based on the vector diagram we can write like this. This is the I naught, the no load input current is the vector sum of IW and I mu, working component and magnetizing component. So, bring this IW in the left hand side. So, I naught square minus IW square equal to I mu square. So, you can rewrite that I mu square equal to I naught square minus IW square. By taking square root on both the side, so I mu equal to square root of I naught square minus IW square. Now, substitute this value, I naught is available 1.5 ampere, IW is 0.4 ampere, these two values are given. So, by simplifying this we got 1.44 ampere, the magnetizing component is 1.44 ampere. So, we calculated the power factor cos pi, magnetizing component 1.44 ampere, as well as the input as well as the no load input power. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.